Today we're diving into something really extraordinary,
It's a story, yeah.
but one that feels like it unlocks the operating system of the universe itself.
It really does. We're using this fantastic story about a boy, Liam, to kind of get our heads around some seriously fundamental truths. Not just fiction, but, well, how reality might actually work.
Yeah, so Liam, he's this kid, maybe not super into fractions, but completely obsessed with how light works.
Right. And his go-to place is his grandpa Orion's cottage. Retired physicist, smells like old books, and burnt toast, apparently. A classic combo.
Totally. And Grandpa Orion sees this spark in Liam, this curiosity, and gives him, well, the ultimate hook. A box.
Ah, the box with that fantastic label.
Oh, not open until you're ready to question reality. I mean, who could resist that?
Exactly. And inside, not what you'd expect. It's a cat, a fluffy gray cat named Pixel, but she's a quantum cat.
A quantum cat. So the moment he sees her, he's basically face-to-face with one of the biggest ideas in physics.
Precisely. Schrödinger's cat. It's the thought experiment, isn't it? Schrödinger used a cat to show just how, well, weird quantum mechanics seems when you scale it up.
And the weirdness is this idea of superposition.
That's it. At that tiny quantum level, things can be in multiple states all at once. So Pixel, in the box, before Liam looks, she's kind of both awake and asleep, fuzzy and sharp. All possibilities exist together.
Until he looks, observation forces reality to pick one.
That's the idea. It's called the collapse of the wave function. Think of it less like a water wave and more like a wave of probability. It maps out all the maybes.
Okay, so Liam opens the box, he observes Pixel, and the maybe collapses. But not into the cottage kitchen.
No, that's where the story takes its leap. The world around him shimmers, dissolves, turns into this strange, glowing, soupy reality.
He's fallen into the quantum realm.
Effectively, yeah. Into the place where possibility hasn't settled down yet. And Pixel,
The cat starts talking, or, well, thinking loudly, as the story puts it.
welcoming him to the quantum realm. Inside the code that runs everything, and bam, there's the quest.
The universe is made of possibilities, and observation, Liam's observation, is what makes reality happen. What a concept.
It's a powerful setup for exploring everything else.
So Liam's there. His cat's now his cosmic guide, and he's floating in this energetic place. Pixel calls it the in-between place where particles play. He sees these glowing dots zipping around.
Like fireflies on caffeine, I think the description was. It's vivid.
Totally. And this immediately brings us to another huge concept, entanglement. He sees pairs of these dots, the quantum twins, Q1 and Q2, acting as one.
Right. They spin together, mirror each other perfectly. And the big question the story raises is how do they talk to each other instantly, even when they're far apart?
Faster than light.
Well, that's the kicker. They don't need to communicate faster than light. They were essentially born connected. They share a single quantum state. If you measure one.
You instantly know the state of the other one, no matter how far away it is. Jupiter, even.
Exactly. That's the spooky action at a distance Einstein was so famously uncomfortable with. It felt like it broke the cosmic speed limit.
But it doesn't.
Modern understanding suggests not. They aren't sending signals. They are one system just spread out. The analogy used is great. One twin in your pocket, one on Jupiter. Yours flips blue. The Jupiter one is instantly blue too. They're mirroring a single reality that isn't confined to one place.
And this connects back to Liam and us, because we're made of atoms.
Trillions of them. So the implication is we're technically entangled with everything we've ever interacted with. It's a connection far deeper than just, metaphor.
Wow. But this amazing quantum synchronicity, it's fragile, isn't it? There's a threat.
Yes, the story visualizes it as decoherence. A giant encroaching shadow of static, of noise.
What is decoherence, really?
It's what happens when a quantum system loses its isolation, when it bumps into its environment too much, gets measured by too many things, or even just gets too warm.
So too many observers, like us, looking...
Or just interaction with the surrounding air molecules. Anything, really. That interaction forces the quantum maybes, the superposition, the entanglement to collapse. It picks a state.
And the magic fades. It becomes...
boring physics, as the story puts it, the definite, predictable physics of our everyday world. It's why your keys aren't usually in two places at once.
So to save these quantum twins, Q1 and Q2, from the static, Liam does something instinctive. He grabs one.
He does. And by doing that, by directly linking himself to this quantum state, the narrative says he's now carrying entanglement energy. Basically, he's become part of the system.
Yeah.
He's now operating under quantum rules himself, potentially able to affect reality. A huge step.
Okay, so he's escaped the static, carrying this quantum twin. Where does he end up next?
Probability space, a place where things literally haven't decided what they are yet. The ground flickers underfoot glass, water, nothingness. It shifts with his expectations.
Unsettling.
Very. And it leads straight into the uncertainty principle. They find this valley filled with floating crystals.
And if Liam tries to focus on where a crystal is,
It starts zipping around uncontrollably. Its movement, its momentum becomes totally unpredictable.
but if he focuses on how it's moving,
Then its exact location gets fuzzy. He can't pin it down.
so you can't know both precisely at the same time. Is that just because our tools aren't good enough?
No, and that's the crucial part. It's not about faulty measurements, it's fundamental. The universe itself seems to prevent knowing these complementary properties like position and momentum with perfect accuracy simultaneously. Measuring one inherently disturbs the other.
Nature keeps some secrets, huh?
You could say that, and then things get even weirder auditorily. Whispers.
Thousands of whispers, right?
Yeah.
Saying contradictory things. Go left, jump, don't breathe.
That's the sound of the wave function in full flow. All possibilities whispering at once. It's overwhelming chaos until Liam learns he has to choose.
He collapses the wave function himself.
Okay.
How?
By focusing, by deciding. He centers himself, focuses on his own breathing, something definite, and by choosing his reality, the maybes around him are forced to settle down, to pick a state that aligns.
Observation shapes reality again. And this leads them somewhere specific.
To the core of maybes, a huge beacon of light representing infinite potential. And this is where the story introduces the multiverse.
Ah, the idea that every choice creates a new universe.
Exactly. The core tells Liam that every decision he ever made, turning left instead of right, choosing cereal instead of toast, split off a whole new reality where another version of him exists, infinite Liams.
Okay, that's a big concept. Is that accepted science?
It's the many worlds interpretation of quantum mechanics. It's a mathematically consistent way to think about quantum measurement, but it's definitely not proven, still heavily debated, but narratively, it's incredibly powerful.
And the story uses it to raise the stakes.
Definitely. The core shows Liam a vision. It's Grandpa Orion, back in the normal world, searching desperately for him.
So entanglement isn't just for particles. It binds people, too. Hearts.
That's the emotional anchor. To get back home, Liam realizes he needs to understand this unity underlying all the possibilities, the connection that holds even across different potential realities.
Quite the challenge. So where does he go from there with this mission?
He and Pixel follow these threads of possibility into the memory field. Imagine a vast plane made of glowing symbols. This is where the universe keeps its records, its receipts.
And they meet someone.
The archivist. A figure made of light who remembers everything but doesn't seem to hold the memories physically.
And the archivist explains how quantum memory works.
Starts with the basics. Qubits. Quantum bits. Unlike our computer bits, which are 0 or 1, a bit uses superposition. It can be 0, 1, or both at the same time, like a coin spinning in the air before it lands.
Which means way more processing power, right?
Right.
But it sounds delicate.
Extremely delicate. And the archivist brings up something called Landauer's price. It basically says that forgetting, erasing even one bit of information isn't free. It costs energy. It generates a tiny bit of heat.
Wait, why? Why does deleting data create heat?
Because information is a kind of order, low entropy. Erasing it means letting that information spread out, become disordered, which increases the overall entropy, the randomness of the universe. And that very process, that spreading out of information from order to disorder.
That's time. The arrow of time.
That's one way to understand it, yes. Time flows forward as information spreads and systems become more disordered. Eggs scrambling, steam cooling. Trying to reverse that, to unscramble the egg or gather all the steam back, requires putting in a lot of energy, essentially fighting the natural tendency towards disorder. The universe finds it easier to just move forward.
Okay, mind slightly blown. What else does the archivist show them?
The classic demonstration of wave-particle duality. Liam has to pass through a veil with two slits, two gates.
First time, no one's watching his path specifically.
And he acts like a wave. He goes through both slits simultaneously. The proof. On the wall behind, there's an interference pattern, bright stripes where the waves overlapped constructively.
But the second time?
Observers. Sentinels track which slit he goes through. And just by knowing the path, the wave behavior vanishes.
No interference pattern.
Nope. Just two simple smudges on the wall right behind each slit. He acted like a particle, taking one definite path. The act of observation, of knowing the which path information, destroyed the wave nature. As the story says, knowing the path loses the song.
And this leads to the no cloning rule.
Right. You can't just make a perfect copy of an unknown quantum state. Trying to measure it precisely enough to copy it actually changes or destroys the original state. You can't Xerox a quantum secret without smudging it.
So how does the universe handle information transfer then?
It relies on things like quantum teleportation, which isn't like Star Trek beaming, unfortunately.
Mhm.
It's about transferring the state, the information itself, from one particle to another, destroying the original in the process.
Yeah.
It moves the knowing of it, not the actual stuff.
So how does Liam get a memory he can actually rely on in this noisy quantum realm?
The archivist gives him topological memory. It's represented as a simple thread tied around his wrist. The memory isn't stored in the thread itself, but in the way the fabric of space-time loops around it, like a knot.
A knot in reality.
Sort of. It's a way of encoding information in global properties, making it much more resistant to local noise and decoherence. It keeps the song, not the footprints. A stable memory for his journey.
Okay, armed with this topological memory, what's the final hurdle?
The final barrier. A massive, solid, completely doorless wall. It looks impossible to cross. They watch tiny glowing particles trying to get through.
Most bounce off.
Most do, but every now and then, poof, one just disappears from the front surface and reappears on the other side.
Didn't go through it.
Not in the way we think. This is quantum tunneling. It sounds like magic, but it's real and incredibly important.
How does it work? Doesn't that violate energy conservation or something? It just skipped the wall.
It does seem like cheating. But remember, the particle is also a wave. And that wave, that probability wave, doesn't just stop dead at the barrier. It sort of leaks. A tiny part of the wave function extends into the wall, into the forbidden region where classically it shouldn't have enough energy to be.
Okay, so a bit of the wave is inside the wall.
And if the wall isn't infinitely thick or infinitely high energy-wise, there's a small but non-zero chance that the wave function will survive its journey through the barrier. If it does, the particle has a probability of just reappearing on the other side.
So it's not digging, it's not finding a hidden door. It's about probability, the odds.
Exactly. It's exploiting the wave nature of matter. It's refusing to play by big world rules where barriers are absolute. And this isn't just theoretical. It's how nuclear fusion works in the sun. The protons don't have enough energy to just slam together classically, but they can tunnel through the electrostatic repulsion barrier. It's also key to modern tech, like scanning tunneling microscopes.
Wow. So Liam has to tunnel himself.
He does. But he learns it's not about brute force. He can't just push through. He has to focus differently.
Oh.
He focuses on asking a small question with a steady heart. He lets the wave part of himself, the probability part, do the work. He embraces the uncertainty, and he manages to send a ribbon of himself through.
He learns that tunneling isn't about time. It doesn't take longer for thicker walls in the same way walking does. It's about chance.
Precisely. The universe isn't necessarily a bully with hard walls. Sometimes it's more like a stubborn negotiator where impossible things just have very low odds, but not zero odds.
What an incredible journey through quantum concepts, all wrapped in this story.
It really covers the core ideas beautifully, doesn't it? Superposition, the world being built from possibilities. Entanglement, that unbreakable connection. Duality and decoherence, how observation limits reality. And tunneling, the hidden potential to overcome barriers.
And Liam, carrying that topological memory thread, he's learned that observation isn't passive. It's maybe the most powerful force there is. He knows not every obstacle is a definite no. Sometimes it's just waiting for that quiet, steady question, that embrace of the quantum maybe.
Which brings us right back to you listening. If we take that many worlds idea from the story, even just as a thought experiment, if your choices, your observations really do branch off different realities.
The you who took the job, the you who didn't, the you who spoke up, the you who stayed silent. If those are all potentially real outcomes in the multiverse.
How much more mindful should you be about the observations you choose to make? The focuses you commit to? Because you might not just be defining your reality.
You might be actively choosing which universe, which version of yourself you inhabit next. Something to think about, right?